Hi everyone, I hope you guys are doing good. So in this video, I'm going to demonstrate you how a linear regression model works. We'll be plotting a graph, and which at initial we do have two coordinates, and we will be using Python and two particular libraries. So just letting you know, we are using NumPy and we are using Matplotlib library. So NumPy is a sort of library which helps you in complex mathematical operations, which includes 2D vector matrices. And then we have also got Matplotlib library. This is the one which is going to primarily help us in plotting the graph. And if you look over here, initially we have defined a variable. So xtrain is the one which will be storing all the x coordinates in the form of vector, and same goes for y coordinates. It's gonna store all the y coordinates we have, and it will be stored as an array, and we will be using the NumPy library for this. So what we have done is that we are in this len function, we are actually calculating the number of data samples we have. As we know, we have defined two samples, so the answer of this one is gonna be 2. So if you look down over here, we are accessing each of the data sample using I. So if we use I, if we use the value of I as 1, we will be getting 2,500. But if as you can see, we are using 0 in this case, we will be getting 1,300. So if you look at the output, let's have a look over here. It says that 1,300. So we can access each of the data samples in this case. So let's start plotting the graph. So what we'll be doing in this case, as we have already got the x train, which has got the array of the x coordinate, and we also have got the y train, we will start plotting the graph over here. If we can ask, what does marker and c means over here? So marker is the symbol that will denote each of the coordinates we have on the graph. So we'll be using X to mark the coordinates, and then we have C over here. C means basically color, so we will be starting that as red. If you want, you can change that to blue or green or whatever color you would like to be. And then the name of our graph is gonna be housing prices. And then in the Y label, I mean the thing which will be written on the Y axis, that will be prices of the houses in thousands of dollars. And then in X coordinates, we are showing the 1,000 square feet. So it's basically a graph which gives you the price of a house depending upon its square feet. So the only factor over here is the square feet, I mean the size of the house. And then using show, we render the particular graph. So let's have a look how our graph is going to look like. So if we go down, you can see that we have got a graph over here. Then it shows us the coordinates, and now you can ask, why doesn't it show us as a straight line? Why isn't it a particular graph? Why is it shown as a coordinate? So if you look over here, we are using scatter instead of plot. So if we would have used plot, it would have actually given us a full graph. So as you can see, this is our particular graph. So what in the second phase, what we'll be doing is we'll be changing the value of our W, and we'll be also changing the value of B. So as you can see over here, just letting you know, W is the weight of the particular graph we are drawing. So I mean the linear graph model. And B is it's the same if you compare it with a linear expression in algebra. A linear equation is the same as y-intercept. So we'll be changing it and see which one fits closest to our actual model. So what we'll be doing is that we have defined a function over here. Over here, at first we are calculating the number of x coordinates we have. I mean the number of data samples is the same as the one which we did with the len. It's the same as that. Let's go down over here, and yeah, so we were over here. So what we'll be doing over here, we'll be calculating new values of y, changing the weight and the y-intercept, which is 100 in this case. So W, instead of saying weight, you can also say gradient. We say it gradient in linear equations. And the new graph which we're gonna do is that we're gonna also do plot and scatter. So if you remember from previously, our actual values is gonna be, our actual value of the model is gonna be denoted using x, whereas our prediction one, where we have changed the value of weight and the parameter b, that one will be our prediction. So the name of that is going to be our prediction, and we'll be using the new values of y in this case. And using legend, we combine the entries of both of the prediction and the actual graph, and we render it over again. So if you look at the one using our prediction actual values, you will see that with the sort of prediction we did, it's actually very different to the one to our actual value. So it's nowhere near to our actual values. And then what we can do is that we can try with a new one, and hopefully we can hope that it's gonna be closer to our actual one and better than our previous one. So let's have a look over here. Over here we are declaring the w value as 200 and b value as 100, and we do the same thing over here again. And just letting you know, C means the color and marker means the actual symbol that will be shown in our graph to show a particular coordinate. So when we use these particular values and use the function to get the new y value, this is the one which we'll be calling every time to get the new values, which is compute model output. So you can see over here, to get the temp fwb, we are using this one. So we will be getting the y value, the updated y value for each of the x values which we have defined before. And so if you look over here, you can see that if we use the newer value, which was w200 and b100, this one is very close and even exactly similar to the actual model we have. So it matches our prediction. So using this model, we can figure out what's gonna be a price of a house which is 1200 square feet. So if you can see over here, what we are doing is we are using the same w value by which we got the exact graph as our actual model. We'll be using the same w value and the same b value, so we won't be changing it anymore because it matched our expectation. And what we'll be doing is that we're gonna do simple mathematical operation over here, just doing multiplication with the w value of the x coordinate and plussing up the parameter over here, and let's see what value we get. So it shows that our actual value and also our predicted value of a 1200 square feet house is gonna be $340. I hope you guys understood what I tried to explain you. This is how we can plot a graph in using Python, and we can plot our linear regression. Thank you.